Okay, here's part 2 of the notes. For torque, for every object, the center of gravity is the same as the center of mass. Center of mass is often called center of gravity, the average position of all the particles of weight that make up an object. For almost all objects on and near Earth, these terms are interchangeable. There can be a small difference between center of gravity and center of mass when an object is large enough for gravity to vary from one part to another. The center of gravity of the Sears Tower in Chicago is about a few millimeters below its center of mass because the lower stories are pulled a little more strongly by Earth's gravity than the upper stories. If you threw a wrench so that it rotated as it moved around through the air, you'd see it wobble about its center of gravity. The center of gravity itself would follow a parabolic path. The Sun itself wobbles off center. As the planets orbit the Sun, the center of gravity of the solar system can lie outside the massive Sun. Astronomers look for similar wobbles in nearby stars. The wobble is an indication of a star with a planetary system. If all the planets were lined up in one side of the Sun, the center of gravity of the solar system would lie outside of the Sun. Right, oops, let me hit my button here, right there. Alright, the center of gravity, or CG, of a uniform object is at the midpoint, its geometric center. The center of gravity is the balance point. Supporting that single point supports the whole object. The weight of the entire stick behaves as if it were concentrated at its center. The small vectors represent the force of gravity along the neck of, along the meter stick, which combine into a resultant force that acts as the center of gravity. So if you put and hold something right there at the center of gravity, use your finger or something, it won't fall because it's being pulled equally on both sides. Just like that hand is doing. If you suspend any object at a single point, the center of gravity of the object will hang directly below it, the point of suspension. To locate any object center of gravity, construct a vertical line beneath the point of suspension. The center of gravity lies somewhere along that line. Suspend the object from some other point and construct a second vertical line. The center of gravity is where the two lines intersect. You can use a plumb bob to find the center of gravity for irregular shaped objects. This is called a plumb bob. The center of gravity of an object may be located where no actual material exists. The center of gravity of a ring lies at the geometric center where no material exists. The same holds true for hollow spheres such as a basketball. So if you see these objects right here, the center of gravity actually is where no actual material exists. And where would the center of gravity of a donut be? In the center of the hole. Can an object have more than one center of gravity? Nope, a rigid object has one center of gravity. If it is non-rigid, such as a piece of clay or putty, and is distorted into different shapes, then its center of gravity may change as its shape is changed. Even then, it has one center of gravity for any given shape. How is the center of gravity of an everyday object related to its center of mass? Alright, if the center of gravity of an object is above the area of support, the object will remain upright. So the box topples when the center of gravity goes beyond its support point. You put this plumb bob on it right here, and once it gets to go over, if you see the box, more of the box, once we do this, more of the box here is over the plumb bob than under it, then it would topple. Our rule for toppling: if the center of gravity extends outside the area of support, an unbalanced torque exists and the object will topple. This Londoner double-decker bus is undergoing a tilt test. So much of the weight of the vehicle is in the lower part of the bus can be tilted beyond 28 degrees without toppling. Pretty funny, huh? The Leaning Tower of Pisa does not topple because its center of gravity does not extend beyond its base. A vertical line below the center of gravity falls inside the base, and so the Leaning Tower has stood for centuries. If the tower leaned far enough that the center of gravity extended beyond the base, an unbalanced torque would topple the tower. So the Leaning Tower of Pisa does not topple because its center of gravity lies above its base. So here's the The support base of an object does not have to be solid. An object will remain upright if the center of gravity is above its base of support. The shaded area bound by the bottom of the chair defines the support base of the chair. Try balancing a broom upright on the palm of your hand. The support base is quite small and relatively far beneath the center of gravity, so it's difficult to maintain balance for very long. After some practice, you can do it if you learn to make slight movements of your hand to exactly reposition to variations in balance. Gyroscopes and computer-assisted motors in these self-balancing electric scooters make continual adjustments to keep the combined center of gravities of Mark Tenney and the vehicles above the support base. Only one side of the moon continually faces Earth. Because the side of the moon nearest the Earth is gravitationally tugged towards Earth a bit more than farther parts, the moon's center of gravity is closer to Earth than it is its center of mass. While the moon rotates about its center of mass, Earth pulls on its center of gravity. This produces a torque when the moon's center of gravity is not on the line between the moon and the Earth. This torque keeps one hemisphere of the moon facing the Earth. So we are always seeing the same side of the moon. The moon is slightly football-shaped due to Earth's gravitational pull. The pull of Earth is actually making it oblong. So what is the rule for toppling again? The center of gravity of a person is not located in a fixed place but depends on body orientation. When you stand erect with your arms hanging at your sides, your center of gravity is within your body, typically 2 to 3 centimeters below your navel, and midway between your front and back. Raise your arms and vertically overhead, your center of gravity raises 5 to 8 centimeters. Bend your body into a U or C shape, and your center of gravity may be located outside of your body altogether. A high jumper executes a Fosbury flop to clear the bar while the center of gravity passes beneath the bar. When you stand, your center of gravity is somewhere above your support base, the area bound by your feet. In unstable situations, as in standing in the side of a bumpy riding bus, you place your feet farther apart to increase this area. Standing on one foot greatly decreases this area. In learning to walk, a baby must learn to coordinate and position the center of gravity above a support force, or your supporting foot. When you stand, your center of gravity is somewhere above the area bound by your feet. You can probably bend over and touch your toes without bending your knees, and in doing so, you unconsciously extend the lower part of your body so that your center of gravity, which is now outside your body, is still above your supporting feet. Try it while standing with your heels to a wall. You are unable to adjust your body, and your center of gravity protrudes beyond your feet. You are off balance, and torque topples you over. So you can lean over and touch your toes without toppling only if your center of gravity is above the area bound by your feet. When you carry a heavy load, such as a pail of water, with one arm, why do you tend to hold your free arm out horizontally? You tend to hold your free arm outstretched to shift the center of gravity of your body away from the load, so your combined center of gravity will more easily be above the base of support. To really help matters, divide the load into two if possible and carry half in each hand, or carry the load above your head, keeping it above your center of gravity. On what does the location of a person's center of gravity depend? That's the end of the notes.